Hi, my name is Kevin Jones, and this is the Java Reference Classes chapter from Understanding the Java Virtual Machine Memory Management class from Pluralsight. Java has always had the concept of strong references. These are our normal, everyday references to objects. When we allocate an object, when we new up an object, we get back a strong reference. And we know that objects will not be garbage collected until all these references are released. So an object will be garbage collected when there are no longer any references to it. However, since JDK 1.2, since Java 2, we've had other types of references available to us. These are special classes in the java.lang.ref package. If you could see me at the moment, I'm making air quotes around special. They're special in the way the virtual machine treats them. It knows these classes exist and it knows it has to deal with these classes differently. And these classes are called soft reference, weak reference, and phantom reference. And we'll take a look at each of these as we go through this chapter and how each of these things work. We'll also take a look at two other things, something called a weak hash map and something called a reference queue, and how these can be used in our application to help us deal with certain scenarios that are harder if we didn't have these special types of weak reference. There are rules when it comes to referencing objects in Java, and the rules are this. The strong reference is stronger than a soft reference. A soft reference is stronger than a weak reference, and a weak reference is stronger than a phantom reference. We already know that an object will never be garbage collected so long as there's a strong reference to it. However, it can be garbage collected if there's no strong reference, but there's a soft, weak, or phantom reference to this thing. On top of this, softly referenced, weakly referenced, and phantomly referenced objects each behave differently to the other. So if I have an object with no strong reference, but it still has a soft reference to it, that object will stay in memory. It'll only be collected if there's memory pressure. So if we're getting to the point where we're going to get an out-of-memory exception, at that point, the garbage collector will run and collect any softly referenced objects. If we have an object that has no strong reference, but has a weak reference to it, then the weak reference is not strong enough to keep the object alive. Now notice the soft reference is strong enough to keep the object alive under certain circumstances. A weak reference will never keep the object alive. So the next time the garbage collector runs, if I have any objects with no strong reference and no soft references, but with a weak reference, then that object will be garbage collected. And finally, we have phantom references. And phantom references are very different to both soft and weak references. For example, if I have an object that has a strong reference to it, and I also have a weak reference or a soft reference to that object, if I take, for example, the weak reference and call its get method, that will return me a reference to the object. A phantom reference does not behave this way. Once I have an object and I have a phantom reference to it, it doesn't matter if that object is alive or not. I can never retrieve the object through the phantom reference. So the phantom reference must be there for something, and we'll see later on an example of where this thing may be used.